Hello everybody, this is the Daily Algorithm and welcome to your first dose of algorithm. Now today we'll be solving LeetCode 1930, unique length-3 palindromic subsequences. Now I'll be reading the question and then help you, give you a little bit of intuition about how to solve this problem along with dry run through the examples, and then we'll build the algorithm and the code together, okay? So without any further ado, let's start this video. So we are given a string S. We need to return the number of unique palindromes of length 3. Okay, so we need to return a count of palindromes that are unique by nature, and these palindromes must be with a size of just 3, okay, that are subsequence of the given strings. Okay, now we need to note that even if there are multiple ways to obtain the same subsequence, it is still only counted once. This is very important thing. We don't have to count the duplicates over and over. We just have to count them once. Now these are the basic definitions. A palindrome is nothing but a string that reads the same from the front and the backwards, okay? And a subsequence is a string that is generated from the original string with some characters with removals or like changing the relative order, but they don't it's the same thing, but with just removal of characters here and there without changing the order they appear. Okay, now let's see this example with the first one. Now we are given with a string a, b, c and a, right? Now the question clearly states that we need to count the palindromes with only size 3. So yeah, let's try to frame the palindromes that satisfy this condition for the given string, right? Now we can form a triple A and A, right? And we can form an A followed by B and an A, right? And also an A followed by a C and an A. Now these are the 3 cases in which the logic satisfies. Now let's try to produce an algorithm out of this steps we just did right now. Yeah, the palindrome which we need to calculate targeting right now is only of size 3, and by the nature of palindrome, if a character starts with a letter X, right, it should also be ending with an X. This is the a base case for this thing, because a palindrome is something that has the same thing, right? If you read it from the forward and the backward, it's the same thing by definition. And by that, if we extend it a little bit, this is the condition we are going to satisfy here right now. Now, what is the character that we can fill in this middle one? That is our target, right? If let's say if we have to fix the first and the last character, we need to count the number of unique occurrences of a character that appears in between the relative position of the first and the second X. That's the whole point of it, right? Now let's say if this is the A we are talking and this is an A we are talking, this A represents the first letter of the palindrome, and this A represents the second letter of the palindrome. Now in order to create a palindrome that is our target, we need at least three characters in this palindrome, right? Now since if we consider this case, we have only 2 characters with us, which does not suit the case actually. So we simply avoid this case. Instead what we do is we try to find another A. Why not find this A, right? If this is the A we are considering 1 and 2, now what are the different characters that we can find in between these characters? That is these unique characters are nothing but a set of A, a B and a C. These 3 can be replaced one after the other in this box, thereby giving us all the unique palindromes that we can calculate from the string. That is the overall intuition. Let's go with the second example. What does the second example say? An A, a D and a C, right? if we consider this example, what we have is that we simply have only 3 characters in our palindrome, and in order to satisfy the condition of the target palindromes, we need to have the first character and the second character as the same character, right? Because as we have discussed earlier, it's a property of a palindrome. Now, if we had to simplify this one a little bit further, now let's say we have an A here. We also need to have an A here, right? But we have only a single A in our string, so we can't technically form a palindrome that is required for us out of this string. So the answer for this has to be a 0. Now let's just go with the third example. Now if we have to consider this third example, we have a B, this B, this B, and B, B. There are 4 occurrences of B and 1 occurrence of a C and 2 occurrences of A. Now out of this, what we can try to form, let's just go with the first initial approach where we just calculated the palindromic strings. And let's say we have a string that starts with B, right? Out of all the palindromic subsequences, we can only calculate a palindrome if it starts with B and starts with A, right? In this string, in this given example, because if a palindrome had to start with C, it also needs a sister C, right? It also needs a pair. So every character that in order to become a palindrome, it's going to need another pair for it. So that's the overall induction in this problem. Now if we had to start with a B, the ending also has to be with a B. Now if these 2 B's had to be considered, right? If these 1 and 2, if these 1 and 2 B's had to be considered, now that means that we can't possibly have another B not just B or any other character lying in between these 2 B's. So we need to go a little further and then pick some other B such that let's consider this B. Now we have a B and a C in between. Let's change the color so that you can understand it. Now we have a B and a C in between. So what we have is that we have a set of a B and a C which together form two sub-palindromic strings out of this given string. But is it the optimal way? I mean, there could be another B lying right after this, because we have an A here. This A is also a possible replacement in this set, thereby contributing to another additional subsequence. Now, so in order to build the logic, what we have to do is that we need to simply calculate the most distant character. If we are considering B, we need to consider the most distant character from this B. That is going to be this character, right? So if this B and this B are considered in the 0th and 2nd index, now we need to calculate the total number of unique characters that lie in between these 2 characters that we just considered. That is going to be B, C, B, A. Out of these characters, we need to consider the unique characters B, C, and an A. Right? Once this is clear, what we did is that we added this extra A to our initial set. Now we can simply instead of we don't have to generate the sequence, right? We just have to return the integer. We just had to count the total number of unique palindromes. So since we don't have to return any string, we don't need to generate them. Instead, we can simply calculate this set. It contains the unique characters that are a suitable replacement for the middle character. Now, and then add this size of this set to the answer variable. Now, there is also an A here, right? We also have an A apart from B, which has a size of 2. if we had to consider two a's on the either edges, we need to find the total number of characters that can again we need to repeat the step we just did. We need to find the total number of characters that is suitable for being replaced in this middle index. Now, in order to calculate this, we need to first find the start index of this A and the end index of this A. These two A's had to they are optimized if they are most distant from each other. There has to be the relative index between these two has to be greatest. Now, if we had to consider this, we have an A, B and an A, right? The index is not, we only have a single B in between these two. So there is only a single unique character. That means we have a single B here, which is a suitable replacement. So that is nothing but, again, we generate this subset that contains the unique characters between the character that lies at the edges, and then simply add this set's size to the answer variable. Now let's just generate the subsequences. Now let's say our string is B B C B A B A, right? Now what we can do is we can simply say B and a B followed by an A and an A. We are simply trying to calculate that set in this region that can provide us an alternative for the middle character. Now what we are trying to achieve here is that if we consider this B and this B, we can have an additional B here, an additional C here, or an additional A here. These three subsequences are going to be a valid subsequence. Now if we had to consider A, now we have only a single B here, so the answer for this problem is going to be 4. If that is very, very clear to you, let's just jump to the programming part. Now what we'll need is we need to return an int. So let's name our answer and initialize with that as 0. Now we'll also need to count the unique characters of our string, right? Counted now we'll simply have to loop through this given string and then note have a record of all the unique characters. Let's do that for RC and given strings. You can simply use unique dot push. No, it's insert, if I remember it right. Of C, I think it's okay. Now once we are done with this loop, we can simply iterate over this new unique set, and then for char and char C of we can simply calculate our leftmost occurrence and the rightmost occurrence with we have a function to do this for us, and in C++ it's string.find of you need to pass in the parameter right is equals to s.find of no, it's a reverse, right? S dot reverse or find of C, and then F. Now we have the leftmost and the rightmost index of this character C. So if suppose if left and right, if they both are same, so that means that there is only a single occurrence of this character, so we don't have to consider this case. So what we can do is we can simply eliminate that case Now what we need to do is we need to like if we have this a and this a in our left and right indexes, that means we need to find the total number of unique characters, right? So we can do this with another set. Let's name it unique. For we can loop from left +1. Right, we are simply adding the unique characters here of the substring. Now we can simply add the size of this map to the size of this set to the answer variable. Okay. I think that's we did a small mistake here. Okay, we need to add this inside, right? Okay, a small scope error, and yeah, once this is in the scope, yeah, we are here. See, we just did it. If you did like this video, please like, share, and subscribe.